In this video, we'll be looking at how we can improve our approximation of a car's speed at a specific moment in time. In the last video, we started by looking at a car that was increasing its speed as it merged onto a highway. And we focused on the amount of change in distance for each 1 second interval. We wanted to approximate the car's speed at exactly 3 seconds after it started to merge. Our general method was to use average speed over an interval of time to approximate the instantaneous speed. We computed average speeds over 1 second intervals right before and after the 3 second mark. Since we knew the car was increasing its speed, this gave us an underestimate and an overestimate for the instantaneous speed. We knew that it would be between 3.87 meters per second and 8.34 meters per second. Our big question now is, how can we make a more precise approximation? It would be good for you to pause this video and to think of a method to get a better approximation before watching anymore. One way to do this is to use smaller intervals of time. Let's look at the car's trip again, but this time break it down into half-second time intervals. As before, let's see how each half-second time interval corresponds to a distance interval. Let's look at the 3-second mark. As we did with the 1 second intervals, we can find an average speed over the interval right before the 3-second mark. Here, the average speed is 2.31 meters per half second. This is equivalent to 4.62 meters per second. Then we can also find the average speed right after the 3-second mark. Here, the average speed is 3.11 meters per half second. This is equivalent to 6.22 meters per second. So this tells us that the car's speed right at the 3-second mark is between 4.62 and 6.22 meters per second. This one is for half-second time intervals. When we used 1 second intervals, we found that our instantaneous speed was between 3.87 and 8.34 meters per second. We can see how accurate each approximation is. Since the half-second intervals give us an approximation within 1.6 meters per second of the actual value, which is smaller than the 4.47 meters per second for the 1 second intervals, this tells us that the half-second intervals produce a more accurate approximation.